Again, learners, welcome back to class. Today, I would like us to talk about trigonometry. This is an area that is challenging, especially these new learners who are in grade 9 and who are so new to this concept. So as a result, I felt it is good for us to be discussing this concept time to time so that we can be preparing for the KJSA and also for proper understanding of this concept. Otherwise, come, let us solve this problem and understand more. Thank you. Now, the height from the tip of a lightning arrestor to the foot of a building is 42 meters. I repeat, the height from the tip of a lightning arrestor to the foot of a building is 42 meters. Nyaemo, whose height is 1.5 meters, stood 75 meters away from the foot of the building and viewed the tip of the arrestor. Calculate his angle of elevation. Calculate his angle of elevation. Now, the secret to trigonometry, dear learners, is basically being able to understand the question and interpret it properly. Let us interpret together. Nyaemo, the height from the tip of the lightning arrestor to the foot of a building. Now, we must create that problem. Let us interpret that scenario where we are talking about this is the height. Then this is the tip of the lightning arrestor. Then this is the foot of the building, whose height is 42 meters. Again, Nyaemo, whose height is 1.5 meter, stood 75 meters away from the foot of the building. 75 meters away from the foot of a building. So we draw 75 meters away from the foot of a building. Here we are. This is 75 meters. Again, we are told that Nyaemo is 1.5 meters high. So the height of Nyaemo, we must create it here as 1.5 meters. So Nyaemo at this point, this is where his head is looking at the tip of the lightning arrestor on top of a building. Here we are. So let Nyaemo look at the tip of a lightning arrestor. Then look at that. That is the whole scenario that we have at the moment, where Nyaemo is 75 meters away and the building is 42 meters. Now, it is at this point where Nyaemo now lifts her head so that she can look at the tip of the lightning arrestor. At this point, so that we can be able to get the angle of elevation. So that we can be able to create this angle, we create something called a baseline at this point. We create something called a baseline at this point. Now at that point, we will have our angle, that is our angle theta. This distance from this point to this point, again, we know it's 75 meters. Now, here comes the problem. You cannot use 42 meters from the foot. Why? Because Nyaemo is not looking at the tip of a lightning arrestor from the foot. He is 1.5 meters high. So at this point, so you must take this 42 minus this 1.5 so that you can have, let us do together, we have 42 minus 1.5, we have 40.5. So the distance of interest, or the height of interest, is 40.5. Now at this point, we can use it to get the height of the building. Now, here is the case, because the question is asking, calculate his angle of elevation. The angle of elevation, this is the angle. We need this angle. So what we do, number one, you ask yourself, in SOHCAHTOA ratio, in trigonometry, what do you have? This one is the adjacent to this angle, and this is the opposite to this angle. Remember, we are not going to use 42. We are going to use 40.5 because we are dealing with this distance from this point, not from this point. So we are going to have tan, because tan or tangent of this theta, is given by the opposite over adjacent. So we are going to have what? We're going to have tan theta, which is given by the opposite over, opposite is our 40.5, or over adjacent, which is 75. Now, for us to get that, we will have tan theta is given by, let us do it together, 40.5 divided by 75. What do we have? We have tan theta as 0.4. Now, for us to get the angle, we will have inverse tan of 0.54, which gives us what? Let us do together. Inverse tan of answer will give us 28 28.37 degrees. So therefore, the angle of elevation to the tip of the lightning arrestor is 28.37. Dear learner, that is the simplest way that you can calculate this problem. Otherwise, the secret is, first of all, understand what the question is saying, then interpret the question. Thank you. Now, the second example from our first example is very interesting and very tricky if you don't understand. Sally measured her angle of elevation of the top of a tower to be 30 degrees. Sally measured her angle of elevation of the top of a tower to be 30 degrees. When she walked 42 meters towards the tower, she noticed that the angle of elevation of the top of the tower was 36 degrees. Find the height of the tower. Find the height of the tower. Now, again, we agreed that we must interpret this problem properly. Solution. Now we are saying that Sally measured her angle of elevation. So, of course, when you are elevating, you must be looking at something that is on a higher level or on a higher ground. Now, let us create the problem here. We are saying that she measured 30 degrees to be the angle of elevation to the top of a tower. So we have our 30 degrees to the top of the tower. This is our 30 degrees. Remember, this one is a vertical height or perpendicular height. When she walked 42 meters towards the tower. So from here, she walked 42 meters. So 42 meters towards the height of the tower, then observed that the angle of elevation now has changed to 36. So the angle of elevation at this point becomes 36 degrees. Remember, this is the foot of that tower. This is the foot of the tower. So now the question is, dear learner, find the height of the tower. Find the height of the tower. So this is where our interest is. Be careful, close attention. This is a very tricky question if you don't understand. Number one, there are things that are missing. Look at this. This distance from this point to where she looked, she elevated and realized that the angle is 36 towards the foot. It was x distance that we don't know. So if we want the height, we can use the ratio tan. We can use the ratio. Let me use this point. We can use the ratio tan 36 degrees is given by opposite over adjacent. Tan 36 degrees is given by opposite over adjacent. That is the first one. The second one, this height can also be given by, or can also be expressed as tan of 30 degrees. Tan of 30 degrees is given by opposite over the adjacent now of 30 degrees from this point all the way to the foot, from initial point to the foot. And this distance is given by what? 42 plus x. 42 plus x. You have to be very, very careful so that you can answer this problem. Again, now, these are two ratios that are giving us the height. So what do you need to do? Make height the subject of the formula, or express this height in both of the equations, then equate it to give you the value of x. So what do I mean? For example, let me call this one equation 1 and this one equation 2. So what are we going to have? We are going to have tan 36 degrees is given by the height all over x. You multiply both sides by x, so you'll have x tan 36 degrees is equals to that one, and that one cancels, is equals to height. That is for equation 1. This one, from equation 1, it shifts to equation 3. Then again, we have the second one, which is tan 30 degrees is equals to height all over 42 plus x. Then you multiply both sides by 42 plus x. So you multiply both sides by 42 plus x. You multiply by 42 plus x. Now, if you multiply that way and cancel that one and that one, you will have a new problem, which is 42 plus x tan 30 degrees is equals to height. Now we have equation 4. Now equation 3 and equation 4 both the ratios will give you the value of the height. Both the ratios will give you the value of the height. Now, let us proceed. Let us proceed, dear learner. So now we know that height is given by x tan 36, or height is given by 42 plus x tan 30. So what do you need to do? You need to equate both of them. X tan 36 degrees, x tan 36 degrees is equals to, this height is also equals to this height, equals to tan 30 degrees into bracket 42 plus x. Then open the bracket for both sides. So we'll have tan 36, which is 0.7265x, because I've multiplied this one times this one, equals to, what is tan 30? Let us get tan 30. Tan 30 is 0.5773 into 42 plus x. Again, let's see, you're having 0.7265x is equals to this multiplied by 42. You'll have 24.25 plus 0, this one multiplied by x, 0.5773x. Dear learner, I hope you're following, and this one applies especially to these grade 9s who are feeling that this one is becoming a problem. Then put the like terms together. Put the like terms together. This is x, this is x. So what do we have? We are going to have 0.7265x minus this one, because it crosses. Remember, this is addition. When it crosses this sign, is this side, it will be subtraction. So you're going to have 0.5773x equals to 24.25. Now let us get the difference. 0.7265 minus 0.5773 is giving us 0.1492x is equals to 24.25. Divide both sides by 1492, 0.1492. So we're going to have 24.25 divided by answer to give us the value of x as 162.5 meters. That is the value of x. That is the value of x. Now, this being the value of x, you replace it here, where you're going to have 162.5. So now, this is the whole horizontal distance. Again, let's go back. We said in equation 1 told us that x tan 36 degrees will give us the height, and our height, our x is 162.5, tan 36 degrees will give us our height. So now what we are going to have is that one, this 162.5, which we have here, multiplied by tan 36 degrees, which will give us the height as 118.09 meters. That is the height of this building. But now the question was asking, find about the height of the tower. This is the height of the tower. Dear learner, this problem is not complicated. It requires you to be able to be open-minded and understand what the question is. Otherwise, keep us posted with your feedback in the comment section. Tell us how we can be of help to you. Thank you very much.